may not finish everything on here. I will try my very best to, but financial maths has some lengthy questions, so I'll get to whatever I can get up to. Just a heads up. Okay, arithmetic sequences and series. This is the first part. So, what is an arithmetic sequence? Basically, an arithmetic sequence is basically when we're adding terms together and they differ by a constant amount. So 1 plus 4 plus 7 plus 10, which has, you're adding 3 and adding 3 and adding 3. So your constant like difference is 3. Another one is minus 3, minus 5, minus 7. So that would be, minus 2 again. So my constant difference is minus 2. And then I know I keep saying sequences and series. You might not know what a sequence or a series is. So sequences and series, pretty much the exact same thing. A sequence is when they're being added together. A series is just when they're listed next to each other. So the example being 1, 4, 7. It's not 1 plus 4 plus 7 plus blah, blah, blah. It's just 1, 4, 7. That's the only difference. Okay. So just some more terminology. A is known as the first term. So when I get to the equations, A is the first term, T1. Okay, Tn means the nth term, and it will be equal to whatever the last term was plus the common difference. Okay, I feel like this will make more sense once I actually go in with an actual question. So let's go in with the actual equation first, and then we'll go through the questions. Okay, to find a certain term, we have the formula Tn is equal to A plus n minus 1 times D. So A, as I was saying before, is the first term. N is the number of terms, so the nth term. And then D is the common difference between the terms. Yeah. And then we're just going to prove that formula for you. So if we know that A is T1, then T2 will be T1 plus whatever the common difference is. So A plus D. T3 will be T2 plus D again. So A plus D plus D. So A plus 2D, which if you just keep going until whatever n, you'll still be boiled down to the same formula. Tn is equal to A plus n minus 1 times D. Okay, so that's also on your formula sheet, by the way. With this in mind, let's try this question. I'm not going to give you any time to go through it on your own, so you can pause if you'd like to go through this. Okay. So Bockham Hills 2018. In arithmetic progression, T2 is equal to 7, T7 is equal to 53. Find the common difference and the first term. Okay, so I'm going to write the equation at the top. So Tn is equal to A plus n minus 1 D. T2 is equal to A plus 2 minus 1, which is just 1, times D. Okay, so I can write that A plus D is equal to 7. Okay, what else can I write? I can write that T7 is equal to A plus 7 minus 1, so 6D, which is equal to 53. So what I'm going to do is you can choose what you'd like to do with this. You're going to have to do simultaneous equations. I'm going to define D. Actually, no, I'm going to define A. You can pick, won't make a difference. So A is equal to 7 minus D. Okay? So now I'm going to sub A is, basically sub 1 into 2. So T7 is equal to 7 minus D plus 6D is equal to 53. 7D is equal to, oh, not 7, sorry, 5D. 53 minus 7 46. So D is equal to 46 on 5. 9.2. Okay. Sub D is equal to 9.2 into the first equation. So A is equal to 7 minus 9.2, which is negative 2.2. Okay, and now my next step is to obviously check. So check by subbing into A. Oh, sorry, 2. So I get minus 2.2 plus 6 times 9.2 is equal to 53, which is correct. So my A and my D. Okay. The next question is to find the value of the first term and the series, which is greater than 1,000. Okay. So let's do the actual equation first. So Tn is equal to A, so negative 2.2 plus n minus 1 times 9.2. I'm actually going to expand these brackets. So it's going to get me to minus 2.2 plus 9.2n minus 9.2, which will get me to 9.2n minus 11.4 is equal to Tn. Okay, so I'm looking for the term value that'll be greater than 1,000. So I'm going to say that 1,000 is equal to 9.2n minus 11.4. 9.2n is equal to 1,011.4. N will be equal to 101.4 divided by 9.2, which will be 109.93, blah, blah, blah. So my next thing is to check what the question is actually asking for. Is the question asking for what's greater than 1,000? So I'm going to sub in 109 into my Tn. 109 will get me 9.2 times 109 minus 11.4. That gets me to 991. We're not there yet. We're not at over 1,000. So if I go to 110, I should be, 1,006. Okay, so therefore, n is equal to 110, but that's not answering my question. The question wants me to know the value of the first term. T 110 is equal to 1,000.6, and that's how we answer this question. Awesome. Let's move on to the sum of the n terms, which is given by these equations, also given on your formula sheet. So Sn is equal to the number of terms on 2 times A plus L. So the first term plus the last term, which is proven in a really cool way. I'll show it to you in the next slide. And from this equation, we can derive this equation, which is also given in the formula sheet. Okay. So the way that this formula was derived is there was this German mathematician, which I can't remember his name, but he pretty much just defined the sum of n numbers to be, term 1 plus term 2 plus term 3 plus term 4 plus blah, 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 which will be, A plus A plus D plus A plus D plus D, and so on, so on, so forth. And then obviously, because they're all being added, if you just flip them over, it'll be the same thing. And then when you add these together, so 2Sn, you'll find that everything cancels with each other except for our A plus L. So you're left with just Sn is equal to n on 2 times A plus L. So that's a pretty cool formula. Okay, so we have a question, also from Bottom Hills. Chris is making a pattern using triangular tiles. The pattern has 5 tiles in the first row 7 tiles in the second row, and each successive row has 2 more tiles than the previous. How many tiles would Chris use altogether to make his first 25 tiles? I'll give you a sec to pause this question and work through this on your own, okay? Okay. Hopefully you have done the question now, and I'm going to show you the working. Awesome. Okay, so the first tile, so T1 is equal to 5, and our common difference is equal to 2. So Tn is equal to 5 plus n minus 1 times 2, which is equal to 5 plus 2n minus 2. So it's equal to 2n plus 3. Okay? Which I suppose I didn't even need to do, but I did it anyway. Okay, now we'll do the sum of 25. So there's 2 ways that you could do the sum of 25. It could be first doing this and then doing the first equation, which is Sn is equal to n on 2 a plus L. My personal favorite, but you'll need to know how to use both equations. So let's check all our variables. So n is equal to 25. We don't have L though, so we'll need to use this equation to find L. So T25 will be equal to 2 times 25 plus 3, which will be 53. Okay, so L is equal to 53. So we can write 25 on 2, 5 plus 53, which my brain couldn't tell me what the answer is. That is, so we'll go 25 on 2, 5 plus 53. That's 725. Another way that we could do this is by putting it directly into our second equation, which is Fn is equal to n on 2, 2a plus, I think it's minus 1d. Yeah. Okay. So n is 25 on 2 times 2 times 8 plus 24 times 2, which will get us to, just in case I made a mistake with my working. Awesome, 725. Okay, so it depends on the situation when you want to use what. A lot of the time you could use either one, but just so you know, even though this equation is a little bit nicer, this one requires less steps of working. So it's whatever suits you best, and obviously whatever the question gives you the circumstances for. But you should know how to comfortably use both, ideally, by the time you get to your trials. Okay,